introducing FPGAOL, an online FPGA service that you can have a try. It's built by the University of Science and Technology of China, and I'm one of the contributors. First, you go to this link provided in the video description, and you don't need to care about the other things. You can just press visitor login, and then there are some boards available. There is a constraint file for the FPGA available. You can just click the acquire. You can have a panel link. You click on it. Okay, you see a panel. This is just like a real FPGA board. It's in the browser, but actually behind this one, there is a real Artix 7 board running there, and it is sampled by a Raspberry Pi, and then the result is sent through the website and to the browser. You can just select a compatible bitstream file, you program, and you can interact it with the buttons, LEDs. There's a UART. There are some other things. And of course, if you want to have a quick start, it will be troublesome to install the heavy toolchain. So we've provided some kind of online compiling services. This FPGAOL compiling as a service. It is customized for this FPGAOL platform for now. You just initialize, and if you're a login users, you're students, you press the 1. If you're a guest, you use the 2. Okay, and you have the basic constraints files and the demo code setup. You can edit it on the fly. Probably you don't need to choose this one or edit this one, but you can add some customization on this side. After that, you just press submit. It'll be really fast because on the back end it is this open xc7 toolchain, which is free and open source and supports 7 series. It even supports the Kintex 7. This is a quite new thing. There are also SymbiFlow, but for us, SymbiFlow uses quite a lot of memory, so we are using this. Okay, it's already finished. It is this fast. You can download the bitstream. Okay, you can download the compiling log. Oh, it takes some time. Here's the log, and you see it's powered by USYS and next pointer. Okay, quite a long log, isn't it? Anyway, if you have some problem, you can have a look. Is there any timing information? It's hard to find anyway. Oh, maybe this is too simple and there's no timing involved, so there's no report. And anyway, the bitstream is downloaded, and you can go back to the to this panel, and you select file. You select the bitstream, press program. Okay, it successes, and you see that it is the logic we programmed, which is just LEDs being assigned by the switches. And meanwhile, on UART there's a loopback. But now the UART doesn't work. It's a kind of bug. But if you refresh the page, the bitstream is already there, and the UART will be working. Of course, this is a standard VT100 UART, and it's in loopback mode. But still, if you press enter, the cursor will only go to the beginning, and if you press Ctrl J, it will go downwards, and so like this. You can have really some fancy like colors and maybe patterns here. You see that this is on the same domain because it's hosted on in the school's website, and if you have difficulty accessing it or whatever, I also have a personal one on my home lab. It's forwarded via a Volta server. This is exactly the same. And meanwhile, you can have a try what are going on if, like, for example, they are missing some keywords. You can still press submit, and it says it fails. You download the log. Okay, you see that on line 15 there's some syntax error. You see that this is exactly where we make the mistake. the error message might not be so user-friendly, but you can get the idea. These two are exactly the same, and if you have difficulty access one, you can try the other. Okay, so this platform is well, it's not that powerful, but it can do many things. And for example, I here have my personal RISC-V implementation, the COSI SoC. It is capable of booting normal Linux, but of course on this platform we don't have a decent way of loading some big binaries onto the running FPGA. So you cannot run Linux on this unless you try really hard, but I don't want to do that. Anyway, here we have some examples and some pre-built COSI SoC images. This is using a big block RAM as the main memory. It has a MicroPython coded inside the block RAM by default, and you can still load some medium-sized sized binaries and RISC-V codes via this little serial port. Like you can select here I have it in the history. You can select the COSI SoC for FPGAOL2. You program, and you flip the rightmost SW0 to reset the processor. Okay, now it boots. It boots from UART, and you see the serial message. If you want to use the default MicroPython, you just press space. It is for booting. Now you're dropped into a MicroPython shell. You can do some very Python things. And yeah, it's like this. And if you want to load some custom things inside, you reset, and you really input some UART to override this running memory, which is some kind of maybe 200 kilobytes of block RAM. For example, here we have the pre-built RISC-V test here. You press raw, and you copy everything, press Ctrl+C. Here you paste, and after a while you press a space to boot. The order doesn't matter. You wait for it to upload, and okay, you have a perfectly running RISC-V test here. And there's also a call mark here, but I won't demo this. Anyway, the originals source codes of this test are available at this software directory. There are call mark, there are tests, and you see the in firmware there's boot-ROM images which prints these introduction lines. Okay, I think that's it. And if you find something or you need to ask something, you can join the Discord server in the link. And if you find some vulnerabilities on the platform, it'll be really nice if you can tell us. Yeah, that's it.